Welcome to this video on limitation of EMF method. Understanding how the EMF method works is essential for grasping the concepts discussed in this video. If you are not familiar with the EMF method, we suggest watching our video on voltage regulation of alternator EMF method before viewing this video. This video will help you to describe the limitation of the EMF method of determining voltage regulation of the alternator. Explain why the EMF method is called a pessimistic method. The limitation of the EMF method is that the calculated value of synchronous impedance, ZS, is not accurate. It is higher than the actual value. In the EMF method, when we conduct a short circuit test, we inject less field current to make the short circuit current equal to the alternator's rated load current. Because of this less field current, the flux density in the air gap is low, and hence, the synchronous impedance value obtained from the EMF method is higher than the actual value. This higher synchronous impedance value leads to a higher synchronous reactance value, which is also higher than the actual value. As a result, the synchronous reactance drop becomes high when we calculate the induced EMF EPH in the alternator. This will result in a higher induced EMF EPH, which exceeds the actual value. When we calculate the voltage regulation using the EMF method, it will give a value higher than the actual regulation value. Hence, the EMF method is called the pessimistic method. So, how can we overcome this limitation? Is there another indirect method to calculate the voltage regulation of an alternator? Well, the answer is yes, there is. You can find the answer in our video on voltage regulation of alternator EMF method.